Hello guys and gals, and welcome to the video on 5.2e. This is the final section of 5.2 before we move on to 5.3 and finalize these notes, okay? So 5.2e is all about the rate constant k, okay? So 5.2e says the proportionality constant in the rate law is called the rate constant, that is k. The value of this constant is temperature dependent and its units reflect the overall reaction order. Okay, so now that we know how to solve for rate law, we can start talking about K. K is called the rate constant, and it's really weird because we've never really dealt with a dependent constant before, but it's going to become very familiar with us as the more that we use it. So it's dependent upon two main things, which is the reaction that you're in and the temperature that that reaction is occurring at. Most people kind of leave out the first part because they expect us to understand that K is going to be different for every reaction. But it's very important that we understand that K is temperature dependent. So even if we're looking at the same reaction, if it's occurring at two different temperatures, K values for each of those reactions is going to be different, okay? So K is temperature dependent. The K constant takes a lot of things into consideration. It takes in the activation energy of the reaction. It talks about the number of particles with the correct orientation to react, the number of collisions occurring, the temperature, and so much more. There's a super long equation to solve for K with all of that information that we're not going to have to do. For differentiated rate law, the only thing we're going to have to be able to do is find the orders to find the rate law and then use that to solve for K. Okay, that's going to make our lives super easy. All we have to do is solve for the order, to solve for the rate law, to solve for K and its units. Okay, so let's do a quick example to figure out how to solve for K. In this reaction, a cobalt and chlorine bond is replaced by a cobalt and hydroxide bond. Okay, and you can see it looks pretty complicated, but it's a simple single displacement reaction. And then here we have all of this information because the question is asking us to find the rate law expression, which is just another way to say what is the rate law for this reaction, and calculate the value of K. This is a very common question on the AP exam, is to ask you to do both of those things at the same time. Well, again, we can't solve for the rate law unless we know the order for each individual reactant. So in this case, they've only given us the concentration of one of our reactants. What that's going to tell us is that they already know that water is zero order. Okay, if you see the balanced chemical equation and you can see that there are two reactants, but in the data they only give you one, that's a very good hint to you that this is probably zero order. The other reactant is probably zero order. Well, so let's figure out this one then, and then that's the only thing that we have to go on for our rate law. Between trials 1 and 2, I can see that the concentration is doubled, and also the rate doubles. So that's nice and easy. The rate law for this reaction tells us is going to be just this. So rate is equal to K. Oh, there we go. Is equal to K. CONH3 Cl2 plus to the first because it's first order. So nice, simple, and easy. Now we can solve for K. And the way that we're going to do that is we're just going to use this rate law in any trial that we want to. Okay? We're going to use any trial that we want to because we have rate of each trial and we have concentration of each trial. They've given us that. So let's use that information to solve for K. So I'm just going to use trial 1 because it's easiest, where the concentration is 1.0 times 10 to the negative third. And the rate, when that is the concentration, is 1.3 times 10 to the negative 7. So when I set it up, this is what it'll look like. 1.3 times 10 to the negative 7 is equal to K times the concentration of our reactant. Notice there's no exponent here because it's raised to the first order. So I don't have an exponent there. Well, and then I can just solve this algebraically. So I go through and I divide the two numbers and I end up that K is equal to 1.3 times 10 to the negative 4. All right, cool. Simple enough, right? Well, here's the thing. Because when they asked us to find the rate law expression, that was nice and easy. We did that after we determined that the reactant was first order, and we were done. When they ask us to find this, the K value, they expect us to also include the units. Because K is dependent upon the reaction occurring, the units of K are going to be different depending on the reaction that's occurring. Specifically, it's dependent upon the order of the reactants that are in the reaction. And so K can help us determine, we can actually use the units of K, and they can help us see the overall reaction order. In this case, because we only have one reactant, it's also the order of that reactant. But the fact is, we have to solve for K's unit, okay? And if you put this on the AP exam without any units, they would not accept it. You have to have the correct unit, okay? So the way that I solve for units is the exact same way that I solved for the numerical value. I just replace these numbers with units instead. So looking at what the information they gave me said, this tells me that the rate unit is in molarity per minute. I'm trying to solve for K, and I already know that the concentration is in molarity, right? So I set up my equation the exact same way that I set up the equation to solve for it numerically. Instead of just using numbers, though, I just use their units. And so I would divide by M. Well, it looks kind of weird to divide by M on this side. So what I can do there to make that easier for me is I can make this 1 over M, because you don't really ever divide by anything, right? You actually multiply by reciprocals. So M is equal to 1 over, or to M over 1 if you were to make it into a fraction. If you're going to divide that and it looks really weird because you're dividing a fraction, and so that's very strange, you can just multiply by the reciprocal, right? So that's some math information that is going to help you out. If you don't understand how that works, come and talk to me, okay? So I'm multiplying by the reciprocal here to make this division part on me easier on this side. And since both of these molarities are on opposite sides of a fraction, I can cancel them out. They're going to cancel each other out. What that leaves me with is 1 over minutes is my unit of K. Or very often, you're going to see it written as minutes to the negative 1 to indicate that it's on the bottom of a fraction, negative K. And that's your units of K. All right? So if I were to go back here, I would not just say my answer is not just 1.3 times 10 to the negative 4th. My answer is 1.3 times 10 to the negative 4th minutes to the negative 1. And that's probably about all there is to solving for K. I've got a few more examples in here for you to look at. And I can tell you that if you only have one reactant and you really like memorizing, you can memorize the units of K if there's only one reactant, all right? Or if you have two reactants that are both first order, you can also do this, okay? So if your overall reaction order is 0, if your reactant has 0 order reactant, then your units are molarity over time, which can be written in several different ways, as we can see right here. But the main idea here is if your overall reaction order is 0, your unit is molarity over time. If your overall reaction order is first, like our previous example was, there was only one reactant, it was first order, so 1 plus nothing, because there were no other reactants, is 1. Our overall reaction order was 1, and so every time our overall reaction order is 1, our unit for K will be 1 over time, or time to the negative first. So in this case, our time was in minutes, so it was 1 over minutes. If your reaction is second order, so that means you have one reactant that is second order or two reactants that are both first order, 1 plus 1 equals 2, then your reaction is 1 over molarity times time, all right? Or you'll often see it as liters over moles times time. So I hope that helped, and we'll move on to 5.3.